Hello and welcome to Assembly Language Programming 8025. In this video, I'll show how to write assembly language program, the subtraction of two 8-bit numbers and also two 16-bit numbers. So let us start with the two 8-bit numbers. So let us consider two 8-bit numbers, and remember in assembly language programming of 8085, the numbers are given in a hexadecimal notation. So we'll consider two numbers, 85, this is hexadecimal number, and also 23. Now first we'll perform the subtraction and find out the result. So to perform the subtraction, we'll convert the hexadecimal into binary format. So the binary equivalent of 8 is 1000. And the binary equivalent of 5 is 0101. You can remember the code 8421. Suppose if it is 8, it is 100. If it is 5, 0, 1, 0, 1. Similarly, you can write the binary equivalent of any hexadecimal number. The second number is 23. So write the equivalent of 2, that is 0, 0, 1, 0, and 3, 0, 0, 1, 1. Now perform the subtraction, binary subtraction. 1 minus 1 is 0. 0 minus 1, so we'll borrow 1 from here. So 10 minus 1 is 1, so it becomes 0 and 0. 0. Again, we borrow 1 from here, so here it becomes 1, it becomes 1, 0. So 10 minus 1, 1, 1 minus 0, 1, this becomes 0. So the equivalent is, this is nothing but 6. And this is 2. So 85 hexa minus 23 hexadecimal number will give 62 hexadecimal number. Now we'll start writing the program. So we'll load these numbers first in the memory location. 8500 will take the first number, that is 85. And 8501, the second number, that is 23. Now let's store the result in 8502. Now let us start writing the program. So to write the program, first we have to consider the address where we have stored the data. So I'll use the instruction LXI H, 8500. So load immediately the HL pair with the address 8500. So HL pair points to 8500, and 8500 we have the first number, that is 85H. Now we'll move that to the accumulator. So we have an instruction called move A, M. So move A, M. M is a memory. So move the contents of the memory location indicated by the HL pair to the accumulator. So memory M always represents the HL pair. HL pair contains the address 8500, and 8500 contains the data 85. So 85 will be moved to the accumulator. That is instruction move A, M. So the first number now is in the accumulator. So previously the number is in the memory location 8500. Now we move that to the accumulator. Now the second number is in 8501. So we have to increment the HL pair so that it points to the next address. So presently it is pointing to 8500. So if you write increment H, now HL pair will be incremented with 1, that is, it will be pointing to 8501, which consists of the second number 23. Now the first number is in the accumulator, the second number is in the memory, pointed by the HL pair. Now we have to perform the subtraction. There is an instruction called subtract m. Subtract m subtracts the contents of a memory location from the contents of the accumulator and stores the result in accumulator, because the accumulator here consists of 85. 85 minus memory is 8501, because here it is pointing to 8501, it is 23. So it performs 85 minus 23, and we have seen that 62 is the answer and will be stored in the accumulator. Now we have to store the result that is an accumulator in a memory location. So I want to store it in 8502. So move. So store the contents of accumulator. Now the accumulator consists of the result in 8502. All. So this is a simple program to subtract two 8-bit numbers. First, we have to initialize HL pair with the starting address of the data, where the data is. So initially we have to upload the numbers in the memory location. So I have chosen 8500 as memory location. So the first data is in 8500, that is 85, and next memory location 8501 contains the second number 23, and result I want to place it in memory location 8502. Now initialize immediately HL pair with 8500. Now HL pair points to the memory location where the data is available. Move A comma M. M is the memory. Move the contents of the memory location addressed by the HL pair. It indicates the instruction move A comma M is an instruction which moves the contents of the memory that is specified by the HL pair to the accumulator. Now HL pair is pointing to 8500, and 8500 consists of the first number, so that will be moved to the accumulator. Now accumulator consists of the first number. Now increment H. Now HL pair will be incremented to 8501, where we have the second data. Now the first data is an accumulator. The second data is in the memory 8501. Subtract M performs a subtraction of the contents of the memory represented by the HL pair from the contents of accumulator and stores the result in the accumulator. This instruction performs the operation. So subtract M. So accumulator minus the contents of the memory location addressed by the HL pair. Now HL pair is pointing to 8501. Its contents are 23. So 23 will be subtracted from 85, and result that is 62 will be stored in the accumulator. Now move that result stored accumulator to 8502. So we want to view the result. So we have to store the result that is in the accumulator to 8502 and halt the program. So this is a program. Now we have to write the opcodes and then feed it in the microprocessor kit. So we'll start with the memory location 8000. And remember, this is a 3-byte instruction because it consists of the address. So LXI H, the opcode is 21, comma. So first we have to give 00, and then the higher address 85. So 8000, 8001, 8002. So next address will be 8003. So this is a single byte instruction. It has the opcode. So move A comma M has the opcode 7E. This is a single byte. Next is 8004. Even increment H is a single byte instruction and its opcode is 23. Next, 8005. It is also a single byte instruction because the operands are specified within the instruction itself, and its opcode is 96. And then next is the 8006, and because the address is specified in the instruction, it's a 3-byte instruction, so it occupies 3 memory location. So STA, the opcode is 32, comma, the lower address, that is 02, and at the higher address 85. So 8006, 8007, 8008. Next is 8009 and then halt 76. So it will halt the program execution. So this is now we have to go to the microprocessor kit and then press examine memory and then press next, then type 8000 and then next start uploading the code as it is until you reach 8009. Then press next. So it will go to 8000 A and then reset and then execute code 8000 execute. The processor is same as you can watch my previous video to know how to upload and execute the assembly language program. So this is a simple program to subtract two 8-bit numbers. So first we have to store the two numbers in two memory location and move first number to the accumulator and then increment the memory location, use subtract m and then store the result in 0. I hope you all understood this program. Now, coming to the second program, that is the subtraction of two 16-bit numbers. So first we'll take an example and then first we'll subtract and then we'll know what is the answer. So I'm taking two 16-bit numbers. My first number is 76, 23, and my second number is 62 and 21. As I told you, we have to convert into binary numbers to perform the subtraction. So write the equivalence of each hexadecimal number. So 7, 0, 1, 1, 6, 0, 1, 1, 0, 2, 0, 0, 1, 0, 3, 0, 0, 1, 1, 6, 0, 1, 1, 0, 2, 0, 0, 1, 0, again 2, 0, 0, 1, 0, and then 1, 0, 0, 1. Now perform the subtraction. 1 minus 1, 0, 1 minus 0, 1, 0, 0, 0, 1 minus 1, 0, 0, 0, 0, 1 minus 1, 0, 1 minus 0, 1, 0, 1 minus 0, 1, 1 minus 1, 0, 0, 0. Now write the equivalence. So 0, 0, 1 is 1, 0, 1, 0, 0 is 4, 0, 0, 0, 0, 0, 0, 1, 0 is 2. So your answer must be 1, 4, 0, 2. Now let us write the program. So first, and one thing that we have to remember is this is the first 8-bit number, this is the second 8-bit, and there can be a borrow from the higher 8-bit number to the lower 8-bit number. Then we have to go for the instruction called SPP. I'll just tell you. Writing assembly language programming for the subtraction of two 16-bit numbers. First, we'll store the 16-bit numbers in the memory locations. So I'll take 7623, the first 16-bit number, and the second 16-bit number is 6221. Now, it will store the first 16-bit number in the memory location 8500 and 8501. Similarly, 8502 and 8503. So the first number is in the memory location 8500 and 8501. The second 16-bit number is in 8502 and 8503. So let us start the program. So LHLE load HL pair with the contents of your memory location given in the instruction. So the instruction is pointing to 8500. So store the contents of 8500 in L and 8500 in H. So HL pair now consists of your first 16-bit number. Now we'll exchange an instruction which exchanges the contents of HL pair with the DE pair. So the first number, 16-bit number that is in HL pair, now will be moved to DE pair. Now DE pair consists of the number 7623. E consists of 23 and D consists of 76. Now, again load the HL pair with the second 16-bit number and give the starting address that is 8502. Now, HL pair consists of the second 16-bit number that is second 16-bit number, right? That is 62 and 21. 21 will be stored in L and 62 will be in the H register. Now, DE consists of first 16-bit number that is 7623. So I'll just write here DE consists of now 7623 and HL consists of 62 and 21. Now for the subtraction, first we have to subtract the lower byte of the 16-bit number, right? So now the two numbers are in HL pair and DE pair. Now the E. So first we have to subtract L, that is 21, from E content, that is 23. So for that, what we do is move A comma E. That is A now consists of the first lower byte number, that is 23. Now directly you can write subtract L. Subtract L subtracts the contents of accumulator L from the contents of accumulator and stores the result in accumulator. So accumulator consists of 23 and L consists of the lower byte of the second number 21 and result will be placed in the accumulator. So result you have seen it as 02. Now accumulator consists of 02. Now we store the result in a memory location 8504. So now the first subtraction result is in 8501. Now the lowest byte subtraction is completed. Now we have to go with the higher byte subtraction of two 16-bit numbers. So first 16-bit higher byte is in D and the second one is in H. So again move A comma D. So the A now consists of accumulator consists of 76 and then SPBH. Now here we have to use SPB subtract with the borrow, because if there is, suppose if there is a borrow from the lower, a higher byte to lower byte, we have to subtract, perform the subtraction with the borrow. So we have to use SPBH, subtract with the borrow the contents of H from the contents of accumulator. Now accumulator consists of 76 minus H consists of the number 62. So 76 minus 62, if it is any borrow is there, the carry flag will be set. So along with that, the subtraction takes place and the result will be stored in the accumulator. So 76 minus 62, the subtraction is 14. Now save that result in other memory location. So STA 8505. So lower byte subtraction result is in 8504 and upper byte is in 8505. All right. So what we have done, we have considered two 16-bit numbers, and then first we have loaded the first number in HL pair and moved to the DE pair, and then we have loaded the second number to the HL pair. Now we move this first number lower byte to accumulator and subtracted the contents of L from the contents of accumulator and stored the result in the accumulator. Similarly, for the higher byte, we have used subtract with the borrow because there can be a borrow from the higher byte to the lower byte of a 16-bit subtraction. So SPP, first we have to move D to accumulator, then perform the subtraction with the H, that is the contents of the H. So SPP H, and once we get the result in the accumulator, store that in 8505. Now this consists of 4, and this will be consisting of the lower byte, that is 0, 2, and this consists of the higher byte 1, 4. So this is how the 16-bit subtraction it can carry on. Now we can write the output. So start with 8000. Similarly, you know that LHLD 8500 byte instruction, but LHLD the opcode is 2A, and then followed by the lower byte of the address and then 85. Exchange as so 3 memory locations it has taken 8000, 8001, 2. Now it is 8003. So exchange EB is a single byte instruction. Next is 8004. So LHLD again is 2A 0285. So 4, 5, and 6. Next will be 8007. So move A comma E is 7B. So you can write it as single byte instruction. So it has output 7B. Now 8008. Subtract L, it is also a single byte instruction. It has opcode 95. Next, store 8504, the 3 byte instruction. So it will start with 8009. A and B. STA is 32 because in hexa, the address also will be in the hexadecimal. After 9, we'll get 10. 10 is nothing but A. So 32, 04, 85. So 9, A and B. So this will be your 8000 C. A comma D is a single byte instruction. So its output is 7B. Next is again 8000 D. It is also a single byte instruction. Its output is 9C. Next is a 3 byte instruction and it occupies 3 memory locations. So D, it will start with the E. So E 32, 05, 85. So E, F, then it becomes 10. So because 20 is nothing but 10 in hexa. 10. Now it becomes 8011. Hot is 76. So this is how we have to write the assembly language program for subtraction of two 16-bit numbers. So to subtract two 16-bit numbers, use HL pair and DE pair. First, note that the first number and exchange to the key pair, and then subtraction must be done byte by byte. First, you have to subtract the first lower bytes of the first the 2 numbers, and then after that you have to perform the subtraction of higher byte of the 2 16-bit numbers. So for that we have moved the lower byte of the first number to accumulator and subtracted the contents of L from accumulator and stored the result in accumulator and moved that result of the subtraction to 8504. The same process repeats, but instead of XUB, if you are subtracting the higher bytes, we have to subtract along with the borrow because there can be a borrow that occurs from the while subtracting the lower bytes. So we have to use SPP calcium and then store the result in 8504. So this is a assembly language programming to subtract to 16-bit numbers, and this is the assembly language programming to subtract to 8-bit numbers. I hope you all understood. Now you can watch the video how to upload and execute the program in microprocessor. Okay, thank you.